then last year it became the top Apache level project. So now we talked about Storm, Dremel, Impala, and Spark, right? Storm is great for streaming. Dremel and Impala, they're good for query processing, querying, right? They're querying tools. But for real-time analytics, the requirements are we want to be able to be streaming, we want to do iterative analysis, we want to be doing interactive, computing. So you need a much more robust framework that will encompass all of this. So Spark is an integrated framework for doing advanced analytics. And in fact, it's the most active project in Apache Software Foundation today. So if you look at it, there are a lot of activities on the community. I have resources later, you can check it out. All right, so how did Spark emerge? Right, we talked about volume, lots of volume coming in, exponential growth of volume. Variety, with lots of different formats, different inconsistent schemas. There's just so much data, unstructured data cluttering around. And velocity, right? The velocity, is definitely, it's growing as fast as the volume is growing. And the requirements for real time is to have interactive computing, like you want to have a very low latency querying tool that can operate as fast as you're thinking, right? You don't want to send a SQL query and sit there waiting for hours or minutes or whatever, right? You want to be really interactive. And you also want to be doing streaming, real time. It's like, all the events are coming. It's like drinking from a fire hose of events. Your system needs to have the capacity to ingest and process everything in real time. So then the value, right? Deriving value out of all of this big data is critical. So, okay, where were we? So predictive analytics is the next step, right? This is where you could use all the statistical modeling techniques, data mining, and do some predictive analytics to look into the current data and look at your historical data and predict what's going to be in the future, right? You want to be able to identify the right risks and opportunities and find out what you want to hit in the future. So lots of businesses. Like credit scoring companies, right? They look into some of your historical data and rank you based on your credit history and figure out if you are able to do a right payment in the future, right? And in the marketing, especially targeted, customized marketing, studying, understanding the customer needs and coming up with the right marketing to approach personalizing. That's pretty critical too. So there's a lot of value. So now all of these efforts, right, volume, variety, and simple descriptive analytics have been addressed by the previous efforts, from the components of Hadoop. But to do something like, more interactive computing, streaming, and predictive analytics is the reason for the emergence of Spark. So Intel is one of the, key contributors. Lots of, adopters, early adopters are evolving. Like in China, like Alibaba, Qiyee, and Baidu in China are coming up, doing something in Spark. And eBay is also pretty active. They have used a Spark framework to one of their, to improve their online retail use case. So they could, provide the right customer experience. So they're doing something. And we have, lots of contributors, 465 contributors to date. Okay, so let's take a look at some of the key benefits of Spark, right? Speed and efficiency, ease of use, and advanced analytics. So it's designed to run, and write fast applications, and it's scalable for more than 8,000 nodes in production. Very low latency. You can, send a query, and you can, immediately, get your response back. It's efficient in memory, it supports all the interactive computing. So if you have a data set, you can extract it, cache it locally, and then query it, keep querying repeatedly. So it's very fast compared to your disk-based systems like Hadoop MapReduce. It's 100 times faster for for certain applications compared to the MapReduce. So definitely it's easy to use. There are lots of APIs. in Scala, Python, and Java that let you manipulate your data collections just like local collections. And there are over 80 high-level operators to build parallel applications, and you can use them interactively from the Python shell and Scala shells. It integrates very well on Hadoop, and you can access pretty much any Hadoop data source. And you can very easily mix all the SQL queries or text or it's designed for general purpose streaming. You can mix everything. So you can do advanced analytics because of all the libraries it has, like graphics and machine learning libraries. You can do more iterative data analysis. You can do more efficient in-memory and real-time computing, right? So it's a distributed in-memory, real-time data processing framework. That's how I would call it. All right, so let's take a look at the stack here. So if you look at this layer below, this is the foundation layer. It provides so the Spark core layer provides the distributed task scheduling, dispatching, and does all kinds of IO functionalities. What it does is it has a fundamental abstraction layer called RDD, which is resilient distributed data sets. It's a memory abstraction layer. You can do pretty much in-memory computations in a fault-tolerant manner. So because iterative compute analysis and interactive computing, in order to do those, you need to be able to reuse your data sets, right? You can use the same subset of data. So data reuse is pretty common, and this really supports the RDD transformations, and the core layer supports all of this. Also, so Spark, the other components are sitting on top of it, like Spark SQL, Spark Streaming, and the advanced analytics libraries like graphics and machine learning. So Spark SQL lets you seamlessly mix all the queries, with Hadoop, with Spark programs. You can do, there's a new abstraction called Schema RDD that has a single interface where you can mix, we call both structured and unstructured data. So Spark Streaming is, it uses the foundation layer's fast scheduling capabilities, and it continuously, streams in and processes in near real time. The way it does is it breaks down the data into mini batches and streams it. It's supported with all in-memory computation in a fault-tolerant manner, especially in real-time systems when your systems needs to be up and streaming 24/7. You want to have you don't want any failures, right? So it's a very good recovery mechanism, especially in Spark 1.2. They've added something called write-ahead logs that will improve drastically your failures and recover from. Yeah. So let me pace up a little more here. Graphics and machine learning are advanced libraries that will help you with for advanced computing, and Spark really runs on various diverse sources, and I'm going to skip through these. It's got a very vibrant ecosystem, lots of distributions, applications, system integrators. They're all in here. I'll walk through a real-world use case here. This is a video serving company where we deployed this for a customer in China. So we did the real-time log aggregation and analysis. So the usage is really, it's an online dashboard. What we're trying to do is we're showing, what are the number of sports cars versus Jeep cars versus family cars. On the right-hand side, you can see. So you want to be able to track those metrics and figure out how many ads you have in interactive BI and view what are the pages and what are the ads and videos, how many, what are the customers looking at, what are they viewing, and then calculate based on, over the last 30 seconds, what are we seeing? Are they seeing more sports cars? Probably yes. That's what I would see. So how does all this work? So there are logs that are continuously collected and streamed. Kafka is a messaging queue that collects the log data, and then on the other side we have Spark cluster that takes the and takes it and streams it onto the non-SQL database. So this is another view where Kafka client publishes to the server, and Spark streaming will distribute it to the every 5 seconds. We are distributing to the non-SQL database. So every 5 seconds there is fresh data in the database, and you can query it and then do all kinds of aggregation of data and monitoring, alerting, whatever you want to the user wants to do. So what is our view of the stack? So you want to do faster decisions, real-time decisions, and improved decisions for your business, right? So the way we look at this is, now, the blue line indicates the real-time path, and the gray line is the batch part, right? So Kafka is a messaging queue that takes the log data, and then Spark streaming will collect the data from Kafka and then streams it to the RDB cache or the non-SQL database. And then on the other side, it's supposed to be green, but the yellow boxes, this is where users are, interactively querying and asking, querying for data. So Spark SQL will kick in, and it's going to take the data from RDD cache or from the non-SQL database, and then it's going to, project whatever his user is asking, right? If it's advanced analytics, then all these machine learning and graphics libraries will kick in. So, messages can also be ETL to the NoSQL or data warehouse sitting on top of HDFS. So depending on the query, Spark SQL can either go to RDD cache to get the real-time data, or get the historical data from the HDFS. So where are we in the community engagement? So we are very actively collaborating with AmpLab ever since the start of the project, right? We have multiple Intel committers, and we are working with them on the Berkeley data analytics stack, and we've done a lot of contributions over there, like GraphX, machine learning, and Takion. So we are working, on all of those components, and we are also, we are very active in the community. So we are working on Spark streaming, Hive on Spark, Spark SQL, and Spark R, right? You can see the industry partners here we are working with, and our current plan from from all those industry partners. I've listed out all the links below, so definitely you can check out. So essentially what we are doing in Spark streaming is we are running streaming computation for every half a second. We are launching a new, new Spark job. And we're working on doing some driver reliability and Kafka receiver reliability. So the links are listed there, and that will really take you to the details of what's being done, and how you can also collaborate or be part of the community. So lots of users are. We have a lot of Hive users. Spark, SQL is definitely the SQL for Spark, but then we want to help the Hive users to migrate onto Spark. So we are working on developing some feature sets on Hive. So our plan is to merge it back into the Hive trunk by this year, and we'll have a beta release. So Spark SQL, we are doing lots of performance improvements. We are coming up with new functionalities, and all these, check out all these links, right? These. Spark R, we are again, we are working on the development. It's complete, and there's an alpha release out there. And but what we are planning to do for the rest of the year is we are looking at doing a lot of performance improvements, and come up with a much more stable release. We are actively engaged with UC Berkeley, and we are working with them. So, oops. All right. So definitely, there is momentum on Spark. You heard this from the panel and from the keynote. So join us at the Spark community. Let's collaborate. If you have any ideas, if you have any applications that you want to collaborate, let's do that. And I have a lot of resources, out there. We have, our architect has written this, one of the top, the paper here. He was, unfortunately, he couldn't join today. So join us for, we have a keynote presentation from Milind tomorrow on Hadoop. What is the next game-changing impact? So definitely join us, and you have our contacts. Jason Dye is our architect, definitely if you have anything, let's collaborate. Okay, thanks,
So,
folks.
thank you, Soumya. Thank you so much for the wonderful presentation. Give a big round of applause to Soumya. So, Soumya will take the questions offline because we are running short of time. So, I will invite Mr. Rana to hand over the certificate.
Sure. Thank you. Thanks.
Uh, the next session is with Mr. Satnam Singh. He is data scientist from CA Technologies. So Mr. Singh is already here. Meanwhile, we'll arrange the presentation for him.
All right. So by the time we're gonna search for my PPT, okay. Well, we can have informal chat here. Just a little bit about myself. I'm a rock climber. I'm gonna start from my climbing story. By the time the PPT comes, and you will realize that. And background is, day to day I do data munging, data cleaning, writing some machine learning algos, work with programmers. I do coding, and then talk to my business leader. So that's the job of a data scientist, and that's what I do. So let me learn more about you guys. How many are data scientists here? One. Okay. How many want to become a data scientist? Yeah, so I had a whole deck on it, but I'm not gonna do So let's hold on to that. Yeah, I have a deck, but I have couple of slides on that. But see, at the end of the day, I'm a PhD, so I need to throw some equations and get deeper into the science as well. So I'm gonna keep a mix and match of entertainment and do little bit of science as well. Just hold on to that, and of course, if there is a board, I can start right here as well. So while you are saying, who's a data scientist, well, if you go to Quora, there is a whole, so there is a whole FAQ on what is what is a data science, and who's a data scientist, and so on. My take on that is actually, it's basically an all-rounder. So if you go in a cricket, right? So you got to know the bowling, you got to know the batting, and you got to have a good field, do a good fielding, and everything, right? So that's what I believe is data scientist is equivalent to do of that, equivalent of all-rounder, but in data science. So I actually happen to be in this area because I was doing my PhD in hidden Markov models, and at that point I was analyzing some of the data from it happened to be in the time when 9/11 happened, and there was a huge rush to do a data analysis because the failure of 9/11 was actually the interaction between multiple agencies was missing altogether, and there was you're not analyzing the data right there. The bad guys were taking the training and everything in US, and somehow it got